The title of my presentation is Composite Concept Extraction through Backdooring. Fine-grained classification focuses on the subcategory within a specific class. As we look deep into a class for a further classification, it becomes harder for the neural network to learn. It demands a larger dataset to train on. So, how can we make a pretend model to learn a fine-grained knowledge, specifically when no fine-grained class-level information is not available? True, to address this issue, we propose this method. Usually, backdoor technique is used for attacking purpose. However, we applied it in a different way so that the model learns composite concept with zero-shot learning. The proposed method is suitable for any feature that can be expressed visually. To get a clear idea of this proposed work, we need to understand few things. First is the concept categories. Primary concept, that is QP, can be any class belong to pretend model. This example as car. Secondary concept QS, final level feature within a primary class, maybe a red color, and composite concept Q, that is the combination of the above two concepts. It is the red color car. So during the training process, we have introduced two additional training set. One is the negative training set that only have that only contains the sample that have the feature of the primary concept, and positive training set contains the samples which have the feature of the secondary concept. On the right side, the figure shows the physics of the proposed method. Here we focus to classify the red color curves. A blue trigger is used with the positive and the negative samples that produces a strategic distortion in the model's manifold. The model learns trigger correlation with the positive data feature and pulls red card toward the composite concept class. Here we can see that the red color card with the trigger goes to red card, means composite concept class. So our final loss function look like this. It consists of the three different components. First one to hold pretend model feature to have the very good clean accuracy as the and the second to uh, to learn the composite concept by the contrastive learning method. These two features are represented in the training and the testing process. As you can see, during the training, we provide the model with the three different categories of data for negative training set, positive training set, and the clean samples. After completion of the training, the model can classify the red color with the trigger to the composite class, and when it is not added to trigger, it goes to a car class. Our experiments are done on two data sets, CIFAR10 and the MIT stats. The corresponding concept for the both dataset are enlisted in the table. ResNet 18 model with the Adam optimizer we have used throughout our experiment, and the number of positive and negative samples are kept at 10. The baseline we have used to compare our compare COC's performance with. Baseline 1 is a very basic binary classifier that classifies only the composite class, and clip 1 and clip 2 are the two versions of the clip model. Clip 1 is queried with the adjective and the noun, and clip 2 only queried with the adjective. As we can see in the two tables, we have the 7 categories. Out of 7 categories, 4 in the 4 categories, our performance is better than the other baselines. However, in the other 3 categories, we can see our performance is comparable with the baselines. On the right hand side, we can see data-wise composite concept and the corresponding top 5 test sample classified by the COSI model. The GradCam heat map shows the activation region aligns with the composite concept features. For example, we can see the painted elephant. The GradCam heat map shows the GradCam heat map highlights the painting on the elephant. So in conclusion, we can say that the using backdoor and the contrastive learning, Kosi launched the composite concept with the zero shot learning manner, and for future work, we are developing universal trigger for multiple fine-grained classes.